Okay, so that's a different question. It says here for number 7, when dragons on planet Pern lay eggs, the eggs are either green or yellow. The biologists have observed over the years that 25% of the eggs are yellow, rest are green. Next spring, the lead scientist has permission to randomly select 65 eggs, consider all possible samples. What is the usual number of yellow eggs in a sample of 65? Usual really means falls within two standard deviations. So the low end, the minimum, is going to be the mean minus two standard deviations, and the maximum is going to be the mean plus two standard deviations. So this is a binomial distribution because every egg has the same probability of being yellow. There's 65 trials. So, and every egg is independent of every other egg. So whether or not one egg is yellow does not affect the other eggs being yellow. So we can apply the binomial distribution to this. So what is the mean of a binomial? Well, that's just going to be n times p, which is the sample size times the probability of success, which is 0.25. So when we get that, I do 65 times 0.25. We get 16.25. The standard deviation of a binomial is the square root of n times p times 1 minus p. So this is the square root of 65 times 0.25. Let's do it this way. Parentheses. Times 1 minus p times 0.75. So when I do that, I get the square root of 65 times 0.25 times 0.75. 3.49. So now I'm going to take my mean, 16.25, and I'm going to subtract 2 times 3.49. And then I'm going to take that same thing, but change the subtraction to addition. So I get a range of about 9 to 23. I believe they always want you to round this one outward. So this should be 24. Round this one down and this one up always. Yeah, and that's all you have to do for that one. This one here says a company prices its tornadoes insurance using the following assumptions. This is basically their fancy way of just telling you that the tornadoes follow the binomial distribution. In any calendar year, there can be at most one tornado. So every year, there's either a tornado or there's not. In any calendar year, the probability of a tornado is 0.03. Doesn't change. So that's our P. The number of tornadoes in any calendar year is independent. So this all is just saying, okay, the number of tornadoes X is going to follow the binomial distribution with 15-year period, and our success is 0.03. So calculate the probability that there are fewer than 3 tornadoes in a 15-year period. Fewer than 3 means find the probability that X is less than or equal to 2. Because it's not saying less than or equal to 3, it's saying strictly fewer than 3. So 3 is not an option. So it's got to be the probability that X is less than or equal to 2. So once you set it up like that, you can say, all right, that's going to be binomial CDF. I have 15 trials. Success in any given trial is 0.03. I'm looking for 2 or fewer. So here I get 0.99006. And there's your answer.